What our next question says that a monochromatic light is travelling in a medium of refractive index 1.6. It enters a stack of glass layers from bottom side at an angle of 30 degree. Interfaces of the glass layers are parallel to each other. The refractive indices of the different glass layers are monotonically decreasing as Nm is equal to n minus m into delta n. Okay, m is the refractive index of mth slab and delta n is equal to 0.1. So, if we keep on going upwards, it will be 1.5, then 1.4, then 1.3, and it will keep on going like this. Okay. Now, the ray is refracted out parallel to the interface between the m minus 1th and mth slab from the right side of the stack. Now, we have to find what is the value of. So, in this case, the medium is getting rarer. So, the ray will keep on bending and in the end it will become parallel to the surface of the slabs and it will come out. Okay. Here if we assume that we are given with negligible small buffer between the glass slabs, or we are given with the buffer of refractive index 1.6 in between these glass slabs. So, what I am trying to say, here we have a refractive index of 1.6 and then we have refractive index of 1.5. Let us consider one very small buffer which has a refractive index 1.6. Again we have refractive index 1.4, and if I take this negligible width of 1.6 again and then it has 1.3, so this keeps on going. Okay. This width is very negligible, so it will not make any difference to the setup which is given to us. As we know, if I talk about now, let us say we have this 1.5 slab and this is 1.6, again we have a buffer of 1.6 on the topmost side. The ray which will be emerging, it will come like this and will deviate and then again. So, the emergent ray will be parallel to the incident ray because this will work as a rectangular glass slab. So, what we can see that for the mth slab, let us say this is our mth slab and we have a buffer of 1.6 here and a buffer of 1.6 here. In this case, when the light will come, it will still have the same angle which is given to us as 30 degree. And if this 30 degree is equal to the critical angle for the mth slab, the ray will be parallel to this and will emerge out. Okay. From here we can put the values. So, it will be like 1.6 into sine 30 degree, that will be equal to Nm into sine 90 degree. Okay. So, now if I put the values, this sine 30, this is equal to half. So, we have 0.8 is equal to 1.6 minus 0.1 into m. Okay. And if I calculate this, so m will be equal to 8, which will be our answer to the problem. Clear?